Objective: to understand one of digital modulation technique, to generate the passcode modulation (PCM) signal using MATLAB, to plot the passcode modulations using MATLAB. What is passcode modulation? Passcode modulation (PCM) is essentially analog to digital conversion of a special type where the information contained in the internal sample of analog signal is represented by digital word in a serial bit stream.
Sampling. Sampling is a process of measuring the amplitude of a continuous time signal at discrete instance, converts the continuous signal into a discrete signal. Sample is a value or set of values at a point in time, or it can be space. The sampling process generates flat top pulse amplitude modulated PAM signal. Quantization. In quantization, an analog sample with an amplitude that converts into a digital sample with an amplitude that takes one of a specific defined set of quantization values. Quantization is done by dividing the range of possible values of the analog samples into some different levels and assigning the center value of each level to any sample in quantization interval.
Encoding. The encoder encodes the quantized samples. Each quantized sample is encoded into an 8-bit code word by using a law in the encoding process. Bit 1 is the most significant bit. It represents the polarity of the sample. 1 represents the positive polarity and 0 represents negative polarity. Bit 5, 6, 7, 8 are the least significant bit. It represents one of the segment quantized value. Each segment is divided into 16 equations.
Question: what is the frequency of analog signal that has been used in the question 1? Generate a 2 kHz sinusoid with a peak-to-peak voltage of 2 V, negative or positive 1 V, and generate a quantized signal when n equal to 8 and n equal to 16.
By using MATLAB, the coding is required to generate a quantized signal when n is equal to 8. This is for 8 level, which n is equal to 3. For the result, the waveform outputs are 5 in total. First one is analog signal and sample signal, then change to encoded signal to decoded signal. The last part, where the waveform is changed to square signal. The peak-to-peak voltage is 2 V, where it is positive 1 V and negative 1 V. The next part is the 16 levels. By using MATLAB, it generates a quantized signal which n is equal to 4. This is the output for 16 levels. First one is analog signal and sample signal, then change to encoded signal to decoded signal. The last part, where the waveform is changed to square signal. The peak-to-peak voltage is 2 volt, where it is positive 1 volt and negative 1 volt. Then, we transfer it to simulating. Part 1 is for sampling. The block diagram consists of signal generator, pulse generator, dot product, multiplexer, and 2 scopes. This is output for the program. For left side is analog and sample signal. Right side is sample signal. For part 2, it is quantization block. In this block diagram consists of signal generator, quantizing encoder, multiplexer, and 2 scopes. The output for quantization block is encoded signal and decoded signal. For part 3 is PCM block, where sampling, quantization, and encoding. In this block diagram consists of signal generator, pulse generator, dot product, quantizing encoder, integer to bit converter, bit to integer converter, quantizing decoder, analog filter design, and scopes. Then lastly, by combining all the blocks, a square signal is produced. The output from the block diagram produces a square signal and generate a full PCM waveform.
Conclusion. With PCM, the amplitude of the sound wave is sampled at regular intervals and translated into a binary number. According to the basic of PCM system, every block is implemented sequentially in MATLAB Simulink.